Session 9.3 Two Dependent Samples. Session 9.1 we talk about two populations proportions. Means we have a two set of the data and the samples are independent and we want to compare the two population proportions. Session 9.2 we talk about two population means, and again the samples are independent, so we want to compare these two population means. But the session 9.3 that is something new. We never mentioned about it on the chapter 7 or chapter 8. This is called two dependent samples, or you could call this as a match pairs. This is talking about we have a two set of the data and these two sets of the data are dependent. The dependent means like both of the data they come from the same subject. This session presents method of testing hypothesis and construct confidence interval involving the mean of the difference of the values from two dependent populations that the data consists of match pair. So these sessions we still have two parts. First part we're going to talk about hypothesis testing. Second part we're going to construct a confidence interval. And this is involving the mean of the difference of the values from two dependent populations. So dependent population is talking about you do have a two set of the data, and for each pair of the data they come from the same subject. So we call this as a dependent populations. For the session 9.2 we're working on the mean of the difference, and this is talking about two independent populations. Means the first set of the data will be independent with the second set of the data. So this is the difference between the session 9.2 and 9.3. And for the pairs must be matched according to some relationship such as before or after measurements from the same subjects. So you could think about it. If I have a group of the people, they want to join the weight loss program. So I do have a two set of the data. First set of the data, that will be their weight before joining the weight loss program. Second set of the data, that will be the weight after they join the weight loss program. So for each pair of the data that will come from the same subject, and I want to find out the relationship before and after the measurement. Okay, match pair samples. Does drinking a small amount of alcohol reduce the reaction time? 16 volunteers were given a test in which they had to push a button in response to the appearance of an image on a screen. Their reaction times were measured. So I will have the screen here and I'm gonna ask the first volunteer, look at this screen and this is the button. When you see the image on the screen, you're gonna push the button. Just like, oh, I see the moon, so I'm gonna push the button and then they're gonna record my reaction time. So they take this test first. Then the subjects consume enough alcohol to rise their blood alcohol level to 0.05%. So after they consume some alcohol, they're gonna take the reaction time test again. So again, they're gonna look at the screen. When they see the image, they're gonna press the button and then they're gonna record his reaction time. So you're gonna see we have a 16 volunteers and we have a 16 pair of the datas. So this is the first one, the blood alcohol 0, means they never consume any alcohol. They take the test. The first guy, his reaction time is going to be 103 milliseconds. And then after they consume some alcohol and his blood alcohol level reached to 0.05%, this guy gonna do the test again. And his reaction time become 102 milliseconds. It doesn't make sense, right? Like normally when you consume the alcohol, your reaction time should be slower. But this guy, after he consumed the alcohol, his reaction time is gonna be faster. So we have the second volunteer do the same thing. And you could see we do have a two set of the data. You could think about it, this is just like the before and the after. And both of the data, they come from the same subject. Okay, both of the data, they come from the same subject. And then you're gonna find out the difference. So we're gonna use 102 minus 103. So you got the negative 1 here. 100 minus 99, you're gonna get the 1. So we call this is gonna be the difference. You're gonna see the D in here. Okay, after you guys find out the difference, you could use your calculator, plug in your data, plug in this data on your L1, go to the stat, go to the cal, one variable statistic to find out the sample mean. Okay, the D bar here means the sample mean of the difference. And also, you could find out what is your sample standard deviation of the difference. Okay. So now we have the difference here. We want to do the hypothesis testing. Okay, before that, we're going to look at the requirement. The samples data are dependent. Okay, one more time. The data, they come from the same subject. And samples are simple random samples. And either or both of these conditions satisfy. This is talking about the central limit theorem. Either the original population is normal or the sample size has to be greater than 30. Okay, look at the notation. The D here, this is talking about like the individual difference, right? Just like here. You should have the difference in here. And then you have the mean of the difference. This is the population mean of the difference. Okay, this is the sample mean of the difference. And then this is a sample standard deviation of the difference. The n, talking about the number of the pairs. So just like my example 1, my n will be equal to 16. Procedure for testing hypothesis for the pair samples. We'll be using the t-distribution. Verify the requirement. Then we'll be using the X step. The first one will be the extract information. Remember on the chapter 9, the first thing you need to do, write it down which one is going to be your mean 1, which one is going to be your mean 2. And then let this one, the mean of the difference, equal to mean 1 minus mean 2. Here it depends on your questions. Sometimes they use the before minus after. Sometimes they use the after minus the before. Find out the n, the sample size, sample mean of the difference, sample standard deviation of the difference, and the population mean of the difference. I'm going to talk about this guy after. Okay, original claim. You're going to see we use the mean of the difference compare with the zero. Same idea with the null and alternate hypothesis. Again, the null hypothesis is always like greater than equal to, less than or equal to, or equal. Alternate hypothesis, it can be less than, greater than, or not equal to. Okay, let me explain this part, why we want to compare with the zero here. So normally from the session 9.1, 9.2, the proportion and also the mean, we always compare two different populations, like the mean 1 and also the mean 2, right? This is the null and alternate hypothesis from session 9.2. But remember that 9.2, we are talking about two population means, and the samples are independent, okay? Means the population wants the data are not related to the population 2 of the data, okay? For these sessions, we are working on two dependent samples. So first one, we're gonna let the mean of the difference equal to mean 1 minus mean 2. Okay, we let this guy equal to mean 1 and minus mean 2. So we're supposed to have this null hypothesis. And this is an inequalities, right? So let me subtract the mean 2 for both sides. So you're gonna get this guy, right? Minus mean 2 here, minus mean 2 here, become the 0. Okay, so what is your mean 1 minus mean 2 equal to? Mean 1 minus mean 2 will be equal to the mean of the difference. So I would just replace it with the mean of the difference. Okay, so I will have my null hypothesis become this guy here. We try to avoid writing it like this way because we don't want to get confused to the section 9.2, the two population means with the independent samples. And also, these sessions, we try to compare two sets of the data that's a dependent samples, so we need to find the difference. Okay, instead of writing on this way, we're going to compare with the 0. Okay, you could think about it, it's greater than 0, or less than or equal to 0, or like even not equal to the 0. Okay, alternate hypothesis. So same idea, I'm supposed to have this alternate hypothesis. Now I'm gonna subtract the mean of 2 for both sides. Okay, and then we know mean 1 minus mean 2 will be equal to the mean of the difference. Okay, so here you go. You will have the alternate hypothesis, the mean of difference strictly less than the 0. And then once again, here, these two guys will be the complementary. Okay? Same idea is going to be applied for these two also. You will have these two null and alternate hypothesis. Okay, when you're working on the left less than in the alternate hypothesis, that will be left tail. Greater than, that will be right tail. Not equal to, that will be two tail. Okay, let's go back to talk about the population mean of the difference. This guy is always equal to your null hypothesis. And on your null hypothesis, this is always have the equal here, right? So that's why the population mean of the difference is always equal to 0. Okay, you could write it down here, equal to 0. Then find the test statistic. Okay, you should get this, find out this from here, from your step 1. After you find your test statistic, this is my left tail example. This point here will be equal to your test statistic. And we want to use the p-value method. So the area of the left tail will be equal to your p-value. Remember, when you're using the t-distribution, how can you find your p-value? That will be the TCDF. Okay, TCDF, lower value from here will be negative 1 in 99. Upper value will be the test statistic. And then the degree of freedom. Degree of freedom will be n minus 1. Okay, n minus 1. After you get the p-value, you could draw the conclusion. Less than or equal to the alpha will be reject. Greater than the alpha, we're going to be fail to reject. Conclusion will be the section 8.1, the 1, 2, 3, 4 conclusions. Okay, this is how you guys using your calculator to do the hypothesis testing. You should be able to find the test statistic and also the p-value. Construct the confidence interval for depending sample. So we still have the formula for the margin of error. So we're gonna use the t-distribution times the difference of the sample standard deviation divided by the square root of the sample size n. Then we're gonna construct the mean of the difference of the confidence interval using the difference of the sample means plus minus the margin of error. After that, you could use your calculator to check your work. Okay, example 1. Research collect the data on the numbers of hospital admission resulting from motor vehicle crash, and results are given below for the 5 days on the 6th of a month and 5 days on the following 13th of the same month. Use the 0.05 significance level to test the claim that when the 13th day of a month falls on Friday, the numbers of hospital admissions for motor vehicle crash are not affected. So we have a two set of the data. The first one will be the Friday the 6th. Second data will be the Friday the 13th. And for this example, the difference is given. So you could find 9 minus 13, you're going to get -4. 5 minus 11, you get the -6 in here. Okay, so for the chapter 9, the first step, tell me which one is going to be your mean 1, which one is going to be your mean 2. So I will let the mean 1 will be the Friday the 6th, mean 2 will be the Friday the 13th. And then now, you're going to write it down, the mean of the difference will be equal to the mean 1 minus mean 2 or mean 2 minus mean 1 depends on the difference from here. So here you could see is the Friday the 6th minus the Friday the 13th. So Friday the 6th will be my mean 1, Friday the 13th will be my mean 2. So my mean of the difference will be mean 1 minus mean 2 here. Okay, now I want you guys find the original claim. So again, for the original claim, the null and the alternate hypothesis, you need to look at the claim statement here. Okay, only with the claim statement. So test the claim that when the 13th day of a month falls on a Friday, the numbers of hospital admissions for motor vehicle are not affected. Okay, are not affected means they will have the same number of hospital admission from the motor vehicle crash. So another way to say the mean of the difference will be equal to 0 because they are not affected. And then the null hypothesis, that's an equal also. Alternate hypothesis is going to be not equal. So we have two tails in here. Okay, look for the formula. Find the formula for the test statistic. Okay, so this is the mean of the difference. You could get this formula. So on the number 1 here, we're looking for the n, sample size n, sample mean of the difference, sample standard deviation of the difference, and the population mean of the difference. Okay, n will be the sample size, right? So we have 1, 2, 3, 4, 5, 6. N will be equal to 6. The sample mean of the difference, you guys can use your calculator to find the sample mean and also the sample standard deviation. So remember that is from the chapter 3 material. Go to the stat, go to edit. You're gonna input the data of the difference. Only input this data to your L1. And then go to the stat, go to the cal, choose one variable statistic. If your data is on L1, you're gonna do second one for the L1. Okay, you should find this data. Okay, and sample mean of the difference, sample standard deviation of the difference, you find it from here. For the population mean of the difference, this is always equal to your null hypothesis, meaning that for these sections is always equal to 0 for this guy. Now I want you guys plug in these numbers to the formula. When you guys use your calculator, make sure put the parenthesis on the top, parenthesis on the bottom. You could get negative 2.860. Okay, so this is gonna be your test statistic. Okay. Distribution, we are using the t distribution, so we will have the normal distribution. And we have not equal to on your alternate hypothesis, so that will be 2 tails. And then the test statistic is a negative. So I'm gonna put it on my left-hand side in here. And we want to use the p-value method. P-value will be equal to the area of both tails. Since we have the test statistic on the left-hand side, so t-distribution using the p-value will be using the TCDF, okay, TCDF. So then figure out what is the lower value, upper value, and also the degree of freedom. So lower value will be negative 1e99, upper value will be the test statistic. Degree of freedom will be n minus 1, so we got the 5 here. And then from here, we only find the area from the left tail. So we need to multiply by 2, okay? Make sure you multiply by 2 to get the p-value. You could get 0.0354, okay? Okay, conclusion. After we find the p-value, we'll be compared with your significance level. So significance level is 0.05. So it's going to be less than or equal to, we'll have the reject. Okay, we're going to reject the null hypothesis. Okay, final conclusion. So look at it here, final conclusion. My original claim go to the null hypothesis, so either number 1 or number 2 conclusion. And then we have reject. So that will be the number 1 conclusion. There is sufficient evidence to warrant rejection of the claim. Okay, part B, find the confidence interval. So we have the formula here. And then our alternate hypothesis is going to be not equal to, so we know this is going to be 2 tail. Significance level, that's a 0.05. Since we already have a 2 tail, so the confidence level will be just 95%. Okay, first, find out the critical value. So we have the inverse t, 0.975. What is the degree of freedom? That will be n minus 1. So we're gonna have the 5 in here. Use your calculator. You're gonna get 2.571. Okay, we got this information from the step 1 here. So now plug into the formula. Use your calculator. You should get the margin of error 3.2968. Construct the mean of the difference of the confidence interval. Use the difference of the sample mean plus minus the margin of error. You should get this one. Go to the stat, go to the test, choose the t interval, enter. So we have the statistic summary. The mean, that will be negative 3.667. Sample standard deviation 3.141. Sample size, we have a 6 in here. And we are working on 95%. Go to calculate. So we're gonna get the confidence interval negative 6.963 and negative 0.3707. That's a little bit off from here because our critical value, we only choose like 3 decimal space. On your calculator, they may get like more decimal space for the critical value, for the difference of the sample mean and the difference of the sample standard deviation. Okay, example 2. Use the sample data below with a significance level of 0.05 to test the claim that for the proportion of height of precedents and their mean opponents, the difference have a mean greater than 0 centimeters. Okay, so first step, we're gonna let the mean 1 and the mean 2 in here. So before I let the mean 1 and mean 2, you're gonna look at the chart from here. I have the height of the precedent 189 and their main opponent 170. So you could see the difference. They're gonna use 189 minus 170 equal to positive 19. So that's why the mean 1 here, I'm gonna let the mean height of the precedent. Mean 2 will be their main opponent. State what is the mean of the difference. Okay, mean of the difference is talking about this guy. I know this is going to be mean 1 minus mean 2. Okay, first figure out what is your original claim. You could see the claim statement here. The difference have a mean greater than 0. So when you subtract it, mean 1 minus mean 2 is going to be greater than 0. So the mean 1 minus mean 2, that will be greater than 0. And this is going to be go to your alternate hypothesis. So you can figure out what is your null hypothesis. And this is going to be white tail. Okay, I have this formula, the test statistic. So I'm looking for these 4 guys here. Try to use your calculator, plug in the difference on your L1, figure out what is your sample size, what is the difference of the sample mean, the difference of the sample standard deviation, and the mean of the difference of the population mean. Use your calculator, you should get this one. And then plug into your test statistic formula. Use your calculator, you should get 0.628 here. So we have the t distribution with the white tail. And then we find the test statistic is 0.628. So we're gonna use the test statistic to find the area of the white tail. So we're gonna use the TCDF. Lower value to upper value, degree of freedom. Okay, you should get 0.2820. Compare with your significance level, that will be greater than. So that's going to be fail to reject. Okay, which conclusion you're going to use? You'll be using the number 4 conclusion, right? Since the original claim go to the alternate hypothesis, and then you're going to fail to reject. So that is not sufficient evidence to support the claim that, and then copy the claim statement. Okay, part B, find the confidence interval. So I have this formula. My alternate hypothesis is going to be white tail. So white tail, we need to make up one more tail. That will be the left tail. So that will be 90% confidence level. Now figure out what is your critical value. Degree of freedom equal to 4. You should get 2.132. Okay, plug in to the formula. You should get 10.8589. Construct the confidence interval. Use the difference of the sample mean plus minus the margin of error. You should get this guy. Okay, example 3. I want you guys with the questions by yourself, and first thing, find out the difference. Okay, on the notes I already put it down. Difference will be equal to after minus the before. So how you find the difference here? 32 minus 21, and then you're gonna get the difference. Okay, with the questions one more time, find out the difference. Okay, you should get the answer look like this. Okay, check your word. Now we're gonna using the if step. So for the number 1 again, tell me which one is gonna be your min 1, which one is gonna be your min 2. So I let the min 1 will be the test score after the chaining. Okay, after the chaining. Min 2 will be the test score before the chaining. Okay, and then we already did like the difference will be the min 1 after minus the min 2, which is gonna be your before. Okay, now figure what is your original claim and what are the hypotheses. The original claim should be the last sentence. Tester claimed that the employee efficiency improved after the productive training course. After they have the training course, their score should be improved, right? So you should have the mean of the difference greater than 0. And then the null and alternate hypothesis. And we are working on whitetail. Okay, find the test statistic formula. And then we need to look for these 4 guys. One more time, you just need to input the difference, the data of the difference on your calculator. Go to the stat, add it, and plug into your L1. And then go to the stat, cal, one variable statistic. You should find this data. After we have the number 1 here, we're going to do the number 4, the distribution. So we have the t-distribution with the whitetail. And we are using the critical value method. So the whitetail, the area of the whitetail will be equal to your significance level, which is going to be given 5%. And then we want to find the critical value. So we have the whitetail, we only have a 1 critical value, and it will be positive. So the area from the left here will be 0.95. Okay, will be 0.95 on the left hand side. So we'll be using the inverse t, area from the left, 0.95, and then the degree of freedom will be n minus 1. So you should get 14. If you are using the TI-83 plus, you need to do the programming. Okay, so just click on the program, find the inverse t, enter, and enter. Plug in the area to the left and also the degree of freedom. You should get this number. This is gonna be your critical value. So let's write down the critical value here. This is gonna be my critical value. Now we're gonna find the test statistic. So plug in this number to this formula here. Okay, use your calculator to see what you get. You should get 1.867. Okay, that will be the test statistic. We are not done yet for the number 4, the distribution. After we find the test statistic, tell me where is your test statistic located. Is this number located in the critical region or is not in the critical region? Okay, this whitetail will be your critical region and this is not in the critical region. So 1.867 is somewhere like here. So this is in the critical region, so we will be reject the null hypothesis. Okay, on the exam, I need you guys show me like this picture. Make sure you told me where is your test statistic located? Okay, step 7, write it down. The reason the test statistic is in the critical region, so we're going to reject the null hypothesis. And then conclusion. So conclusion, the original claim go to the alternate hypothesis, so it should be number 3 and number 4. And then we have reject, okay, reject. So that will be number 3 conclusion. There is sufficient evidence to support the claim that employee efficiency improve after the productive training course. Find the confidence interval. So we have greater than 0, white tail. So we need to make up the left tail 4.05 again. So that's a 90% confidence level. Okay, now figure out what is the critical value. Degree of freedom, that will be 14. Use the calculator, you're gonna get 1.761. Okay, plug into the formula. You should get margin of error 4.528. Construct the confidence interval. You should get this guy. So that's it for the section 9.3.